Hello everyone, welcome. Today is day 3 of Advent of Code, and that's what we'll be doing in this live stream. We're going to be solving day 3 of Advent of Code 2025. And yeah, I don't think that's going to take up an hour. So then we'll see what happens towards the end of the stream. Hello everyone in the chat. If you have any questions, you know what to do. Feel free to type your questions in the chat, to type any comments you might have, and if at some point anything comes up, yeah, just let me know. Great, so let's show you the problem statement. I'm not going to read this out loud. I'll give you the gist of it. For part 1, we need to take these input strings. Your input will be a series of strings that contain digits. And the objective is for you to, in each string, find the largest number you can write, the largest 2-digit number you can write, knowing that the order of the digits must match the order of the digits in the number must match the order of the digits in the string. So for example, for the very first string, the largest number you can write is 98. But for the second one, it's not 98, it's 89, because the 8 needs to show up on the left of the 9. So that's the gist of the of the problem statement. Now, I'm not entirely sure why. I mean, I have an idea, but for some reason, when I saw this problem, I thought of pairwise. So let's close this. Let me open the terminal. If you're on Python 3.10 or later, in the module itertools from the standard library, there's an iterable called pairwise. And if you have something like a string, if you have any iterable, you can use pairwise to get access to overlapping consecutive characters of the string. So the pairwise on your S is going to be BA, and then AN, and then NA, and then AN, NA again, and finally AS. Now, why does this matter? Because I thought, well, one way to solve this problem with the digits is to try every single combination of picking a digit for the tens place and a digit for the units place, and check if it's the largest found so far. But I wanted to solve this by going through the string only once. And then I thought, alright, well, the tens place can come from any of the first positions except the last one, and the units place can come from any of the positions except from the first one. And somehow that's how I thought that pairwise might come in handy. I'm going to go through my number, taking these pairs of digits, and then at every point I'll check if I have a tens digit that's greater than whatever I already have, and I'll check if the units digit is greater than everything or anything I already saw. And now in hindsight, I'm not sure this is very clear. Let me know in the chat, let me know if this made any sense whatsoever. I'll try to explain slightly better with an example. I think that's going to help a bit. Let's do 1, 3, 4. Let me think. 2, 3. All right. So given the 1, 3, 4, 2, 3, the correct answer is going to be 43. Sorry, I said 43 and then circled the 2. So the correct answer is 43. So what I'm saying is, I'll start with the candidate number as 0, 0. And then I'll look at these digits and I'll I'll compare the 1 with the 0, and I'll see that 1 is larger. So what I'll do is I'll replace this with whatever I'm holding now, which is going to be 1, 3. So this is the largest number I found so far. Then, pairwise, we'll look at the next sequence of digits, and it will grab the 34, and I'll compare the 3 with the 1 in the tens place, and I'll see that the 3 is greater than the 1. So I'll replace the 1, 3 with the 3, 4. And then pairwise we'll look at 4, 2. Again, I'm comparing the 4 with the 3, and because 4 is greater than 3, I'm going to replace 34 with 42. And finally, we get to 23. Now, when we look at the 23, the 2 is not larger than the 4. So I don't need to replace it. But when we compare the 3 and the 2, we see that the 3 is larger. So I replace the 2 with the 3. And we get 43. And because we're using pairwise here, these little trays that are selecting 2 digits at a time, we're only going through the string once. So this is the idea I had. I'm not sure why I thought of this, but this is what I imagined. Now, any questions about this process of going through the string, grabbing pairs of consecutive digits? Wouldn't it fail if 2 is 4? So if the 2 here is a 4, fail in what sense? So if we had 1, 3, 4, 4, 3, when we get to the 4, 4, it's going to beat the 34 we had. So we keep the 44, and then we go to 43, and the 4 matches the 4, so we don't swap, and the 3 is lower than the 4, so we don't swap. Maybe something that wasn't clear because of this particular example I picked is that we can also just replace the units, not the tens. So let me think. If we had something like 9, 1, 2, 3, the correct answer should be 93, right? 9, 3, obviously. With pairwise, we start with 91, and that's the best so far, so we keep the 91. And then we look at 12, and what's the key here is that every time pairwise is holding 2 numbers, we're checking a candidate for the tens place. So the 1 is a candidate for the tens place, but the 2 is a candidate for the digits place. Apologies for my handwriting. And because the 2 is greater than the 1, we strike out the 91 and we replace it with 92. Or rather, we strike out the 1 and we replace it with a 2 to make 22. And in the next iteration, we have we grab the 23, and the 2 isn't larger than the 9, so the tens place stays put. But the units place, the 3 is larger than the 2, so we strike out the 2 and we replace it with the 3 to get 93. So in essence, every pair that pairwise gives you is a possible replacement for the tens place, but also for the digits. And those are all looked at independently. So let me know if this helped clear things up, and now we can look at the code that implements this process. All right, I'm glad it made more sense now. So what does this look like in code? So from itertools we import pairwise, and this is only in Python 3.10 or later, which you should all be using either way. My function to parse the input is going to accept the file path, and it's going to open it in read mode. And today we don't have to do a lot. We just take the batteries to be the contents of the file, and then we split the lines. So now we get a list of strings, and each string contains the digits that we need to go through. So we need to go through a list of batteries. And now we return our batteries. And then part 1 accepts a list of batteries. And we're going to go through each battery. And we're going to call an auxiliary function which is going to look for the max voltage of a battery. I'm just using the terms from the problem statement. And this max voltage is the 2-digit number we're looking for. So max voltage of a battery. Now we do the digits, the best digits so far. We start off with a 0, 0. And now we go through the tens and the units in the pairwise of the battery. And now we check, is the tens greater than the best tens digit we have so far? Because if so, we need to replace it with the tens, but also we need to replace it with a valid units digit, because the one that we have so far, or that we have at this point, is from a previous location. So we just completely replace best digits by the list with the tens and the units. But if not, if the tens digit we're looking at is not better than what we have, we check if the units digit is better than what we have. Because if it is, we pick that one instead. Batteries should be banks. Probably yes. Yeah, I think so. Why did I call these batteries? Let's see. Problem statement says batteries, and the batteries are arranged into banks. Right. Apologies. Yeah, so batteries, these should be banks, and a single battery is a bank. All right. And then we return the integer that you get if you join the 2 digits. So we go through each bank in the banks, we compute the max voltage, but we want to sum this, so what we can do is actually we sum the max voltage of each bank for each bank coming from the banks, so for bank in banks. And then, if this is being run as a script, we're going to take the banks from the input. Do I have a file with the correct name? Yes, I do. And then we print part 1 of the banks. And now we run this. Will it work? Hopefully it does. UV run solution.py. No, it does not. Oh, because I forgot that of course. So the bank is a string of digits. And in here I'm trying to compare, when I start, I'm trying to compare a string that comes from the input with my best digit, which is a 0. The way I could fix this in a couple of different ways, but I can start off with strings. I can compare them as strings, because since we're comparing single digits, the string comparison will match the integer comparison, and in the end we convert to an integer. What did we get? What did I get? 16854. Let's check. 16854. There you go. So this is the solution to part 1. Let's open the code. This is what the code looks like. Let me know if you have any questions. I'll do an awkward silent pause to drink some water. It's nice indeed, Ivan. Nice indeed. Now, is this the only way to solve this problem? Well, absolutely not. But yesterday I was thinking about pairwise, and so when I read the problem statement, I immediately thought of pairwise. And it's kind of nice because this will exactly. And the follow-up question in the chat, will this work for part 2? Well, yes, not with pairwise, but with the generalization. So I got very, very lucky because just yesterday, let's see. Yesterday, in a Python newsletter called PyCoders, that's like a very big Python newsletter, they shared one of my articles called Generalizing itertools.pairwise. I wrote this article a couple of weeks ago, and they shared it in this newsletter. And this is exactly what we're going to need. So I just opened my article and copied the code. How does pairwise compare to itertools.combinations? Well, it's much nicer because combinations will, or rather, let's start like this. Pairwise goes through the input just once, so it's linear on the size of the string. Whereas combinations, because for part 1 you only care about combinations of 2 elements, pairs, combinations is quadratic. In general, it's not quadratic. In general, it's worse, but because the 2 is fixed, it's always 2 digits, it's quadratic. So using combinations would be, slower in terms of theoretical computational efficiency. Let me know if that helps, bad coded. Yeah, and then an example in the chat showing how you get much more, the output is much larger for combinations than for pairwise in terms of length. All right. So how do you take this pairwise idea and apply it to part 2? Now, I kind of got lucky because I didn't know what part 2 was going to be. But if I go to this article of mine, very convenient, I'll paste it in the chat just in case it's helpful. You will find 3 different ways of taking itertools.pairwise and generalizing it. Well, actually, before talking about the generalization, it's going to be easier to understand the generalization if we know the problem we have to solve. So for part 2, very quickly, it's a very similar problem, but now instead of looking for 2-digit numbers, we're looking for numbers with 12 digits, which is much larger. So an approach using combinations, I think, would be much slow. Well, it will be much slower. I just don't know if it's slow enough that you cannot actually run it, or if it's still bearable if you leave your computer crunching some numbers for a while. Alright, so now we want 12-digit numbers. So this dance I was doing here, let's go through this example. The dance I was doing here of grabbing some numbers and comparing them one by one or digit by digit with whatever I have best doesn't depend on the number or on the amount of digits I'm grabbing. I was grabbing 2 digits because that's what the problem asked. But I can do this with however many digits I want. So if I have a really large number, let's pick an interesting one from this. This is an interesting one. 2, 3, 4. Let's copy and paste. And now make this much larger. Alright, so with 12 digits, it's going to be a pain to write. So we'll just do it with 4 digits. But then if it works with 2 and 4, it's going to work with 12. We start with our best number so far, which is 4 zeros. And then we grab the first 4 digits in a row. And we take this as a candidate for the thousands place, a candidate for the hundreds place, a candidate for the units place, and a candidate for the for the tens place and for the units place. 2 is greater than 0, so we replace the whole thing. Now we have 2, 3, 4, 2 as our best number so far. 2, 3, 4, 2. Then we grab the next set of 4 digits. That's going to be 3, 4, 2, 3. And the 3 is greater than the 2, so we get rid of whatever we had. And 3, 4, 2, 3 is our best guess so far. And then we grab the next sequence of 4 digits, and that starts with a 4, which is better than the 3, so we get rid of it, of the old one, and we take the 4, 2, 3, 4. This is our best so far. And now the interesting part kicks in. When we grab the next set of 4 digits, that's going to be 2, 3, 4, 2. 2, 3, 4, 2. Now the 2 is worse than a 4, so we don't do anything. But the 3 in the hundreds place is better than the 2. So what we do is we get rid of the 2, 3, 4 and we replace it with a 3, 4, 2. And now we get 4, 3, 4, 2. Alright, now this is becoming messy. What's the next set of... Now this is kind of hard to read, so we can pretend we're skipping and suppose that later on you grab the sequence 3, 4, 2, 7. So we don't know what happened here because it's getting messy, and then we're comparing the 4, 3, 4, 2 with the 3, 4, 2, 7. Again, the 3 in the thousands is worse than the 4, so we don't want it. But the 4 is better than the 3. So we care about it, and we replace the 3, 4, 2 with the 4, 2, 7. And so you get 4, 4, 2, 7. And for the very last iteration, you're holding the digits 4, 2, 7, 8. Now, the 4 in the thousands is the same as the 4, so you don't do anything with it. The 2 in the hundreds is worse than the 4 in the hundreds, so you don't do anything with it. But the 7 in the tens place is better than the 2. So you get rid of the 27 and you end up with 4, 4, 7, 8. So the idea of using pairwise will work if you have a function that gives you windows of the correct size. Pairwise gave us windows of size 2. Now, for the example we ran with this diagram, you would need windows of size 4. And for part 2 of the actual problem, you need windows of size 12. Does this make any sense, or is this just messy? Completely random, arbitrary. Python Morsel says they need to be consecutive, I believe. No, they do not, because, for example, here, well, I'm assuming you're saying consecutive, the digits from the number. It's okay, don't worry, Trey. The digits of this solution here, you're skipping. They don't need to be consecutive. They don't need to be consecutive. Yeah, exactly. They don't. And this, but did it look like they needed to be? Because in here we're grabbing stuff that's not consecutive. This 4 came from the beginning. The 4 in the hundreds came from the middle, and the 78 came from the end. Yeah, alright, so that's why, exactly, so I may have misunderstood because you mentioned pairwise, which made me think consecutive. Pairwise is just the way that I use pairwise is just the way that I use to look at the same time at a possible candidate for the tens place and a possible candidate for the digits place. Because in a number, something like 13443, I know that the first digits, all but the last one, these are candidates for the tens, and the last digits, all of them but the first one, these are candidates for the units. And by using pairwise, I get to test candidates more or less at a useful time, because whenever I find a better tens, I can automatically get a valid units. So that's why I used pairwise in the first part. Alright, I hope this makes sense. Because I find, meanwhile, I've seen another neat solution online, another very efficient neat solution, but this one made a lot of sense to me. Let's take a look at this in code. So first I'm going to copy my own code that generalizes pairwise. You can implement this generalization in a lot of different ways. Using dec and islice is a very reasonable one. So I'm going to paste this here. And let me move the... Right, using compress for part 2, trying to use compress with the secondary list as a mask. I guess that's going to be messy, because compress does a single pass, and whenever you pick something, a new digit, you will have to build a new mask, I think, right? I don't know. Compress doesn't sound like a good way to go. Why isn't the generalization in the standard library? I don't know. Pairwise was only added in 3.10. Because actually, to be fair, this isn't used that often. I guess that's the reason why. So let's just see this in action very quickly. I'm pasting the code here. If I have something like, what was the num? Yeah, let's do the list of nys, a bunch of letters. With 2 as an argument, I get pairwise, but I can change the argument to get 4 letters, 4 consecutive letters, and then overlapping. All right, so this is nys. How do we solve part 2 with this? So we get the banks, and we just do the same thing. So we sum the max voltage. We sum the max voltage of each bank, but max voltage that we defined before expects or assumes you're looking for pairs of digits. So now what we do is we replace this with an n, so that we can specify how many digits to use to compute the max voltage. So for part 1 we used 2 digits, and for part 2 we're going to use 12. So the same code will solve both parts, which is I'm really happy when I get to write an advent of code solution where the code for part 1 and part 2 are essentially the same. So what we have to do now is just take this code, this logic, and make sure it works for any number of digits instead of just 2. Yeah. So how do we do this? Well, we're going to go through the possible digits, or the candidate digits, given by nys over our bank, with these windows of size n. And now what we need to do is we need to compare the most significant digit of the candidate digits with the best digit I have so far in that position. And if that's good, we replace all of them. If not, we look at the second most significant digit, and then the third most significant, and then the fourth most significant, up until n. So you could do something like, for digit index in range of n, and then you compare the current best digit with the candidate digit at the given index. But instead of doing the range of n, I can actually zip the two together, the best digits and the candidate digits, to make it easier to compare them with each other. So this is the best digits and the candidate digits. This is getting long, so I'll do the best digits and the candidate. No, that's going to be terrible because B and C. Okay. The best and the candidate in the zip of the best digits and the candidate digits. So now I can compare them one by one. And I can check if the best digit is worse than the candidate digit, then I want to replace this digit and the other ones to the right with whatever comes from the candidate digit. But for this, I need to know the index I'm in. Is this the most significant one? Is this the second most significant, etc.? So actually, I want to enumerate the zip. How long is this line of code? 96, pretty long. Let's do for, I don't even know how to split this. I needed smaller names here. Let's do, will this work? I don't know, for in. Maybe the in goes here, I don't know. And now, if the best digit is worse than the candidate digit, I take my best digits, or at least this one and all the ones that follow, and replace them with the candidate digits starting at this one and also using everything that follows. So this piece of code, the comparison and the slicing assignment, encapsulates this logic of checking the tens and then the units. And in the end, we just return the join. I think that's it. Before celebrating, let's make sure I didn't mess it up, and then we can take a second look at the code, assuming it's correct. It's not because I have invalid syntax here. Where is the problem? For... Oh, of course this doesn't make sense. I can't split a line like this. Why did you folks let me write this? I blame you. I blame you. Alright, I can do this. No, this is terrible as well. Okay, let's do the following. I'm gonna remove it so the data gets unpacked here. Usually I would unpack in the loop, but I'm using very long variable names for the sake of the stream, and the line was too long, so this is how I decided to split it. Alright, let's run the code. It runs. What's the solution I get? 167 something something 2478. Let's compare. 167 something something 2478. Alright, so the code is correct, which means it may now be worth looking at it for a second. Let me know what you think. What are you thinking? What's clear and what's not clear? And what's cool about this is that we're only going through the bank once. So this is pretty efficient and blows the combination solution out of the water. I mean, you could see this ran essentially instantaneously. Yeah, looking at this problem at 3 AM in the morning is not a good idea. Yep. Other questions or remarks? All right. In that case, I mean, I know typing can take a while. Oh, okay, my slice from end part 1 accidentally set me up for an easier part 2. Ah, nice. Okay, I see. Yeah, this works well. I mean, there are a lot of different ways of solving this. Another possibility from the chat is first find the maximum digit in the valid positions. Because again, we know that the first digit must come from this. So you find the maximum, you find the largest one, which is the 4. And then you know that the units must come from here. So you find the maximum here, and it's the 4, and you get 44. But this also works well for longer sequences of numbers. Can I delete all of this? I probably cannot. Let's see if I can copy just the text. All right. So now you do the same thing. You look for the maximum here, and it's, if you want 4-digit solutions, 4 digits, you know that the largest digit must come from here to the left. So you find the maximum, which is the 4. Now you know that the maximum for the hundreds must come from here. So you look for the maximum, it's the 4. The tens must come from here. And note how every time I draw the ending on the right, I move closer to the end of the string. The tens must come from here. The maximum is the 7. So it's this one. And then the units must come from here. It's a single element, and you get 4, 4, 7, 8. This is just another, oops, what did I do? I did something wrong. This is just another way of solving it. And there are more. And I saw another very clever solution somewhere on the internet using a stack. Very efficient, more efficient than mine. Yeah, mine is fun, as Trey says in the chat, because of the enumerate and the zip and the NYs all together. And then the deep unpacking here. I use it from time to time. So it's not the first time I enumerate a zip. So sometimes I do this. And when I enumerate the zip, I have to do the deep unpacking. But the enumerating the zip is something I do from time to time. I'm thinking I'm going to be doing these streams in case you're watching and you don't know, until the 12th of December, which is when Advent of Code publishes their last problem for 2025 at 5 p.m. UTC. And it's now essentially 5:40, so I've been here and you've been here for roughly 40 minutes, and this was only day 3, which is supposed to be quote-unquote easy. I'm not sure how the stream's gonna go once we get to days, I don't know, 8, 9, 10, 11, 12. We'll see. Maybe maybe the rhythm will be faster. Maybe I pick up the pace. I don't know. Alright, the problem is solved. You can find me online to ask any questions at any point in the future. I don't see more questions coming in at this point. Yeah, exactly. So now the plan is, you've heard a couple of ideas. You're going to close the video, you're going to close my code, and you're going to try to do it on your own. And it's a good way. It's a good way to learn. If you struggle a bit with the problem, if you can solve it, you can maybe take a look at the solution or get some hints, and then you try again. Yeah, so for today the problem is done, folks. Thank you for watching. What I'm thinking now is I'm going to let me show you. So there's this project on PyPI called Advent of Code by a friend of mine and a Python Lisbon meetup co-organizer that gives you like a more structured way of what do you call it? Of structuring your Advent of Code directory. Sorry, I don't know, the words were struggling to come out of my mouth. It gives you a structure for your directory, and if you if you name the files in the correct way, or if you just follow the naming conventions that the Advent of Code module sets up for you, you get nice commands like running the benchmarks and things like that. So I'm thinking of just changing the names of my files to match what Advent of Code tells me to do. So that's what I'm going to do in the... I have 20 minutes. I don't think I'm going to need 20 minutes for this. I think this will take me 10 minutes. Let's see. They have... The Ange created a very nice documentation, so this should be easy to do. Now I need to think, because I want this to work for any year. I will set up 2025 and then we'll see what happens. Alright, so I need Advent of Code, and I can run the init command from Advent of Code to create my structure. So let's do that. So this is my 2025 folder. It has 3 folders, 1 per day, but Advent of Code wants me to have a file per day. So I'll run the init command to do that. Let's see, let me also paste the link for this in the chat in case you want to take a look at this later. So I'm gonna run this with uv Advent of Code init. That's not what I meant to do. uv tool run Advent of Code init. Is this how it works? I think so. Alright, so now I have the scaffolding for the structure. There's 01, 02, 02, 03. Now it tells me to set my session cookie. Session cookie, before we can run these files, I need my session cookie from the browser. So I'm gonna go to Advent of Code. I need my developer tools. And then where are my session cookies? What did it say? I have no idea how to find this. Navigate to application storage cookies. Application. I have no idea what I'm doing. Storage. Storage and then cookies. And the session cookie is this one. Alright. Now I copy it. And probably I paste it in this file. Alright. Now, strictly speaking, probably I shouldn't have shown it to you because you can go back and pause it and take my session cookie and do nasty stuff and pretend you're me. But let's trust that that won't happen. So the session cookie is set. Run and submit my solutions. Alright, so now let me take the code. Let me take the code from my day 3 solution. I have Visual Studio here. Let's copy this. And now let me close the thing and open 03.py. Where is it? Here it is. Now the file has a predefined structure. And Ange wants you to write the functions part 1 and part 2 that take your input and then return the result. And this bit here is to help you write tests for the code. So we'll take a look at that later. Let's start by setting up these functions so I can paste my code. I don't need the code that runs. Now part 1 and part 2 will accept the full string, so the banks are actually, I need to parse them here, so it's going to be banks.splitlines. This is the input. And for part 1 it's going to be the same thing, so I get the input, the banks are the input split. I don't need the function parse input. What else do I need? Let's see what the documentation tells me run and submit. This will run your day one with inputs provided. If your correct answer was correct, the same repeat processes. Okay, let's see what happens. Let me remove this because I don't want any asserts. Let's do UV tool run advent of code. And now what is it? It's run 03.py. Alright, nice. So it's working correctly. Now I need to tell Anje that this isn't great because I already solved it. It tried posting the solution, but it failed because it's already solved, but I get the correct one. And now part 2 is not running because I have an assert here. So these are essentially like test cases, the smaller test cases you can use to check your solution. I'll remove them. And then I get the answer for part 2 already. As well, sorry. The answer to part 2, which is correct. Alright, now let's see if I can... What happens if I try to run the whole thing at the end of code? Benchmark. Nice. So it fails for days 1 and 2 because I haven't filled them in yet. And for day 3, we see that part 2 is being solved in essentially 17 milliseconds. It's gonna vary a bit each time I run it, but it's pretty fast. All right, this is cool. I need to fix parts 1 and 2 so that I can benchmark the whole thing. But I don't think I'm gonna do it on stream. All right, folks. Did I paste the link for this in the chat? Yes. This is the project. It's a package called Advent of Code by Anje. You can use it if you want. You don't have to do it. It does a couple of nice things like doing the automated tests following this specific format. You can read it in the documentation. You can do a couple of other things with this. And like I said, I'm going to be back tomorrow at 5 p.m. UTC to solve day 4. Thank you so much for watching, and I'll talk to you folks later. Bye.